student of standard 9. Hope you all are enjoying the study. Now the second level of understanding the motion, that is the graphical concept of motion. So in this particular video, we are going to discuss what should be the nature of the graph. There are two kinds of graph up to your standard. That is number one, XT or ST graph, and number two, VT graph. What should be the nature of the graph of the different kinds of motion, that we are going to discuss. Graphical concepts of motion for standard 9. Part 1, position time graph or XT and ST graph. Number 1, when an object is at rest. So we have to, what should be the nature of the graph? Just to imagine the object is at rest, and usually we are taking the t in the x-axis and x or s in along the y-axis. Object is at rest from the origin. Say for example, one car is at rest at 10-meter distance or something. So here the time axis is there, time is increasing but distance is not increasing. So the nature of the graph is like that. A line which is parallel to the x-axis, you will get it, parallel to the time axis. That should be the case when the object is at rest. Number 2, when object is moving with uniform motion. Object is moving with uniform motion. So again we have to draw the graph or the plot the nature of the graph. Here x or s, here the time axis, this is the origin. Then you will find the uniform motion means object is moving with uniform motion, means equal distance in equal interval of time. So you will find the graph is like that, straight line parallel to the x, straight line passing to the origin, straight line passing to the origin. Now from this graph, how will you find out the speed? You can take any point. Say I have taken here the 2 points, point number A and this is point number B. Drop a perpendicular onto the x-axis like that, and along the and onto the y-axis also. Join this line, you will get the right angle triangle here, right angle triangle ACB, right angle triangle. So this particular distance is equal to this distance, and this distance is equal to this time. This is net time del t, and this is your del x. So speed is equal to, what should be the speed here from the graph? That is your BC by AC. BC by AC. I have denoted by this distance by del x. Small distances here. Why we have taken this del x and del t? Del x is along the x-axis, which is the distance, and this del t, which is equal to the AC, along the time axis. So distance by time. So that should be, or we can say, we can write perpendicular by base. This is the slope of the graph. So if you want to find the speed, you have to find the slope or this P by B. In higher classes, you will find that that is also equal to tan theta. This is the way how we are going to find out speed when the Object is moving with uniform motion, right? Del x by del t, or BC by AC. That's the slope. You can you can take anywhere, here, anywhere this small right hand triangle, and you will find the same value of the speed. Next case is that distance time graph for the non-uniform motion. Here the two cases arises, दो केस आएगा यहाँ पर. Number one, when speed of the body increases with time. Take some table and then we have to draw the graph. Non-uniform motion के लिए. Say for example, one data I am taking x in a second and distance in meter. 1 second distance is 1.5 meter. 2 second 3 meter. 3 seconds 6 meter. 4 second 10 meter. 5 second 15 meter. 6 second say 21 meter, and so on. So how we are going to draw the graph of this? Here what we are seeing that it is non-uniform, unequal distance and equal interval of time. So in this particular case we have to draw the graph. Distance along the y axis and time along the x axis. Here the distance and here the time. So 1, 2, 3, 4, 5, 6 like that. And similarly here we can plot the mark the scale, different scale. If we are going to plot it properly, the same graph 1, 1.5, 2, 3 like that. On the graph if you are plotting, you will find the graph will be in this manner. By plotting you will find. It is speed up. For same interval of time, the distance travel is more if you are going in a higher. So same data if you are going to plot, you will find this. Second case, when speed of the body decreases with time. Another data we can take t and x. Say for example, you can plot also t in second and x in meter. So 1 second, 2 second, 3, 4, 5 like that. 1 second distance moved is say the 10 meter. 2 second distance moved is 16 meter. 3 second distance moved is 19 meter. Right? On the, and 4 second distance moved is 21 meter. 5 second distance moved is 22 meter. Say this data I have taken. Now you have to plot it. If you are plotting this data properly, same in x and t way, xt graph, distance time graph, what should be the nature of the graph? Nature of the graph you will get This is the y axis, x axis. This is y, x, and t. You will find, if you are plotting, you will find that it is like that. That should be the nature of the graph when its speed decreases. Right? After plotting, you can use the graph paper also, or on the plain sheet you can mark the scale x and y and plot it. You will get the graph like that. So the distance time graph, non-uniform. If the speed increases like that, then the slope increases. So it is speeding up, and in case of if the speed decreases, we have to draw in this way, and here the slope decreases. So speed decreases, right?